Welcome to Precalculus Concept 24E. Underneath trig functions and the unit circle, we are going to recognize and use what are known as fundamental trig identities. These are really important, and we want to make sure that we have these in our note. There's 4 boxes. So, sorry about that. Here's box number 1. The first thing that we're going to talk about are what are known as the reciprocal identities, and these should look very familiar to you. So the reason they're called reciprocal identities is because they're reciprocals of each other. So the way that I have it set up, I have sine and then cosine and then tangent, and then below that I have cosecant, secant, and cotangent. And you've seen me do this in class. So the sine of theta can be equivalent to 1 over the cosecant of theta. And then therefore the cosecant of theta can be equal to 1 over the sine of theta. So notice that these are reciprocals of each other. The cosine of theta can be equal to 1 over the secant of theta, and the secant of theta can be equal to 1 over the cosine of theta. Again, these are reciprocals of each other. Tangent can be equal to 1 over the cotangent of theta, and cotangent of theta can be equal to 1 over the tangent of theta. So the reason they call these the reciprocals is because they are written in terms of 1 over something. Each of these can be written in terms of 1 over something, and so that's what makes it a reciprocal. I don't think this is anything new, but now it's formal and it's in our notes. Okay, box number 2 is called the quotient identities. So there are only 2 of these. The tangent of theta can be rewritten as the sine of theta divided by the cosine of theta. So these 2 things are equal. We have an equivalence statement here. Notice this is not a reciprocal because it's not 1 over something, but rather it's 2 trig identities being divided by each other. So we call it a quotient identity. So if the tangent of theta can be rewritten as sine over cosine, or y over x, as you may know, that means the cotangent of theta can be written as the cosine of theta over the sine of theta. Since the cotangent is just the reciprocal of tangent, I can then switch these around and say that cotangent is equal to cosine over sine. So these are our 2 quotient identities, and they are very useful. Okay, let's do an example and put these into use. Let's say that we have been given that the sine of theta is equal to 2/5 and the cosine of theta is equal to rad 21 over 5. Find the value of all 4 remaining trig functions. This is a pretty straightforward example. So let me show you how it works. So we've been given that the sine of theta is 2/5. Okay, so I know that the sine of theta is equal to 2/5. Well, since I know that the cosecant is the reciprocal of the sine, that means the cosecant of theta is equal to 5/2, right? Now the cosine is equal to, in the problem it tells me, radical 21 over 5. So that means that the secant is equal to 5 over radical 21. But we are never allowed to leave a trig identity in terms of a radical on the bottom, so we rationalize the denominator by multiplying top and bottom by rad 21 over rad 21. And this gives me 5 radical 21 divided by, I hope everyone realizes that the square root of 21 times the square root of 21 is just 21 itself. So therefore I have 5 rad 21 over 21. Okay, now tangent. What do we do about the tangent? Well, remember, we realized that the tangent is equal to the sine of theta over the cosine of theta. The value for the sine of theta is 2/5, and the value for the cosine of theta is radical 21/5. Now, like I did in class the other day, if you're dividing a fraction by a fraction where the denominators are each the same, they can cancel out, and that leaves you with 2 divided by a radical 21. The same thing goes here. We're not allowed to leave it like this, so we multiply top and bottom by radical 21, and we get 2 radical 21 over 21 for our answer. Okay, now since the cotangent is the reciprocal of tangent, I can just simply take the reciprocal of this value here. I don't need to worry about anything else. So this will just be rad 21 divided by 2. And these are all exact values, and we use trig identities to get all of the values. Notice I didn't need to draw a picture for any of this anymore. Box 4 is probably the most important box in all of trig identities. These are called the Pythagorean identities, and I want to take just a moment to develop one of them so I can show you the other 3. Okay? Let's take, for example, this picture. Everybody should be familiar with a right triangle. Not a big deal. Notice that I have this side labeled as A, this side labeled as B, and the hypotenuse labeled as C, and I am referring to this angle theta in the lower left-hand corner. We all know from geometry that the Pythagorean theorem states a squared plus b squared equals c squared. That's nothing new. Let's take it for a moment and look at the sine of theta. Let's consider that. We know the sine of theta is equal to the opposite, which in this case would be b, divided by the hypotenuse, which in this case would be c. We know the cosine would be the adjacent, which is a, divided by the hypotenuse, which is c. We know that the tangent would be the opposite, which is b, divided by the adjacent, which is a. And we also know from our trig identities from above that the cosecant must then be c over b, the secant must be c over a, and the cotangent must be a over b. Okay, so just for a moment, let's consider this. Let's consider a squared plus b squared is equal to c squared. That's nothing new. But watch what I'm going to do. I'm going to divide everything by c squared on both sides of my equation. Okay? Now, since I have a fraction that they're both being raised to the power of 2, I can rewrite this as a divided by c squared plus b divided by c all squared equals, what is c squared divided by c squared? Well, that's just a value of 1. Okay, now ask yourself, what is a divided by c? A divided by c is a value of cosine. But notice it's squared, so if I write cosine squared of my angle theta, plus, look at b over c. b over c is sine. Sine squared of theta, it's equal to a value of 1. And that right there is probably the most important trig identity that we have. Cosine squared of an angle plus sine squared of of that same angle has to be a value of 1. Now, if I do the same thing, and instead of dividing by c squared, if I divide by b squared, and then again by a squared, I would develop these other two trig identities. So let me give them to you. The next one is going to be 1 plus tangent squared of theta is equal to secant squared of theta. The next most important trig identity. And the third one would be 1 plus cotangent squared of theta is equal to cosecant squared of theta. And I will be happy to show you the algebra, but it looks just like this. So the takeaway from this box, ladies and gentlemen, is that these are, highlighter. These are super important. Cosine squared plus sine squared is 1. 1 plus tan squared is equal to secant squared, and 1 plus cotan squared is equal to cosecant squared.